Okay, here in Unit 2, we're starting to investigate the structure of arguments and sentences from a logical point of view. So, the first thing that we're going to look at is an argument. This is obviously one of the key terms that we're going to be using over the course of this class, since arguments are what we're studying here. We're looking to find out when arguments are valid, when they're good arguments, and so on. So, what is an argument? Well, when it comes to logic, when we talk about arguments, we're not talking about, shouting matches between people, spouses, or hosts on CSNBC. Instead, what we're talking about are a series of statements in which one of those statements, called the conclusion, is meant to follow from or be supported by the others, called the premises. So an argument is just this: a structured set of sentences with premises intended to offer support for a conclusion. So if we consider an example here, let's just consider an argument that I've discussed or I mentioned in class earlier today. So that would be this following argument. Cats are mammals. Mammals are warm-blooded. Therefore, cats are warm-blooded. Okay, so here's the argument. It's clear that this has a kind of conclusion to it, something that we're meant to be convinced of. That would be the following. Cats are warm-blooded. It's nicely identified by this word therefore, which identifies that we're approaching a conclusion. And this conclusion seems to follow from these two premises. So we might rewrite this argument in the following form. Cats are mammals. 2. Mammals are warm-blooded. And then we can use the following symbol to identify a conclusion. Cats are warm-blooded. So this is the way we might take just a paragraph that's stating an argument informally, this guy, and restate it in a way that identifies the premises and the conclusion and shows how those fit together. Additionally, we might have something like the following. We might write it as follows. Cats are mammals. Mammals are WB. I'm just going to write that for warm-blooded. And therefore, cats are warm-blooded. So either one of these two forms are ways that we're moving from a paragraph, again, this guy, to a more formalized statement of the argument. This one, in particular, is going to resemble how we're setting up arguments to construct proofs or derivations later in the term. Okay, a few more things to note here. If we're looking at these arguments, or in identifying these arguments from this paragraph, notice that we use the word therefore as an indicator of our conclusion. So if you see the word therefore, that's a good indicator that you're dealing with the conclusion. Similarly, hence, thus, then, and so are all going to identify a conclusion or be useful in identifying a conclusion as well. And similarly, there are statements that identify premises. So since, because, given that, and more are going to identify the premises that should lead us to a conclusion. And again, premises are the starting points that are used to lend support to a conclusion, and conclusions are the claim the argument is trying to establish. Now, in the previous argument that we had written out here, cats are mammals, mammals are warm-blooded, therefore cats are warm-blooded, it happened to be the case that the conclusion came at the end of the paragraph. And as our book notes, in natural languages like English, sometimes arguments start with their premises and end with their conclusions. But this isn't always the case. And as you're working on the practice assignments that are included in this unit, I want you to bear in mind that you won't always find the conclusion simply stated at the end of the paragraph. Instead, you should pay attention to these clue words, to these indicators, which will alert you to the presence of a conclusion or a premise. Okay, let's have a little practice with this then. Let's look and see how we can apply these concepts we've just used with some of our practice problems. So in your assignment for today, there are many different practice problems that are included, and you can work on identifying premises and conclusions, putting these into more of a logical form using these examples. So let's look at a couple of these examples. So I pulled out some of these from here. I think I'm just going to do the first two. So we'll look at this homework. This problem 2 from homework questions and practice problems A. So that's on the third sheet of your unit handout. And we'll also look at class activity number 1, which is on the second page, a little bit more of a complicated argument. So we're interested in investigating what is the conclusion in this first argument. Again, the argument is clearly all squares are quadrilaterals. After all squares are rectangles. All rectangles are parallelograms, and all parallelograms are quadrilaterals. Okay, so in identifying this argument, we might first think, well, are there any words that indicate premises or conclusions here? So just remind ourselves of what those are. Things like since, because, given that, identify premises, and things like therefore, hence, thus, then, and so on, identify conclusions. So it doesn't seem that any of those words appear here. However, there are words that are similar to those words. So, for example, the words after all are very similar to since or because. So maybe this is a cue that this is one of our premises. All squares are rectangles. And also at the same time, the word clearly is similar to a word like so or thus, which identifies that someone else should accept this thing. So, we know that these aren't the only conclusion indicators and premise indicators. So I think these guys, given their similarity, are suggesting that this is the conclusion and these other items are the premises. So let's go with this as the conclusion. All squares are quadrilaterals. And for our premises, we have one here. All squares are rectangles. And we have another. All rectangles are parallelograms, funny word. And 3, all parallelograms are quadrilaterals. And it seems to follow that if this is true, then we get squares are rectangles. And if squares are rectangles, that gives us squares are parallelograms. If parallelograms are quadrilaterals, then that gives us squares are quadrilaterals. So we've gotten down here to squares are quadrilaterals via these premises and conclusion. Okay, that's one argument. Let's look at another example. This one, the second example is reminiscent of a famous argument by the philosopher Gottlob Frege, who was Frege. Excuse me, wrong person. I meant by the philosopher Leibniz. And Leibniz is going to argue as follows that this is the best of all possible worlds. He famously makes this argument. So I gave you a little clue there that that's what he's arguing for. But let's just use our clue words to try and indicate what the conclusion is. And we see one of those right off the bat. So here we have a sentence. So this world is the best of all possible worlds because God is both omnipotent and all good. So is this our conclusion? Well, we might think so at first because it starts with this idea of so, which is again one of our indicators of a conclusion. But this weird thing happens here. There's this other word in this sentence, because, which is a typical indicator of one of our premises. So this sentence seems to include an indicator of a conclusion and an indicator of a premise. So what's going on here? Well, the answer is that the English language isn't always going to mirror the underlying logical structure of an argument. This is one sentence, but it isn't just one logical sentence in the nature of our argument. In fact, the conclusion of this argument is this world is the best of all possible worlds. So we'll put that down here. This world is the best of all possible worlds. And we'll also take this phrase starting with because as its word, and we'll suppose that this is a premise. God is both omnipotent and all good. Okay, so we have God is both omnipotent and all good, and somehow we're supposed to get to this world is the best of all possible worlds. Well, how are we going to get there? We have this sentence, God is the creator of the world, but that doesn't seem clearly related to our conclusion. Let's think about this sentence instead. If this world is not the best of all possible worlds, then God is either not powerful enough to bring about a better world, or God did not wish this world to be the best possible world. That seems like it's clearly related to our conclusion. After all, the first part of that, if this world is not the best of all possible worlds, is essentially the opposite of our conclusion. This world is the best of all possible worlds. So, let's write this down as another premise in our argument. If this world is not the best of all possible worlds, then either God is not powerful enough to bring about a better world, or God did not wish this world to be the best possible world. Okay, so does this work to get us to our conclusion? Well, in fact, it does. What we need to bear in mind here is that when this philosopher, or when philosophers in general, philosophers of religion, talk about omnipotence, what does that mean? That means all-powerful. And typically, when philosophers of religion, and especially Leibniz, when he talked about God as being all good, what that means is causes no harm. So, what does premise 2 say? It says, if this world is not the best of all possible worlds, then either God is not powerful enough to bring about a better world, but if that were the case, then he wouldn't be omnipotent, and we're told in premise 1 that God is omnipotent, so this thing can't hold. Or, alternatively, God did not wish this world to be the best possible world. But if God did not wish this world to be the best possible world, then he would have wished harm to the inhabitants of this world, and that would have been contrary to his nature as well. So in fact, these two premises lead us to the conclusion that this world is the best of all possible worlds. We don't even need the premise that God is the creator of this world, though of course that's entailed by the other arguments. Okay, I'm not going to cover this one. I thought I would originally, but I'm going to set that one aside. Okay, let's go back and look at the nature of sentences in logic. Okay, so we've just seen with the last argument we discussed that sentences in English are not always the same as sentences in logic. Sentences in logic may be smaller in a certain sense than the sentences in English. Within a single English sentence, there may be multiple premises or multiple conclusions, each of which we would count as independent sentences within a symbolic logic representation of an argument. So what is a sentence for symbolic logic? Well, for our purposes, a sentence is capable of expressing a proposition. So a sentence is something that can be true or false. A proposition is just something that is capable of being true or false. So anything we treat as a sentence will be capable of being true or false. So it follows from this that we're not going to treat questions or imperatives or some other forms of sentences as sentences from a logical point of view. From a logical point of view, only declarative sentences count. But sentences that express opinions, on the other hand, can count as sentences for our purposes. For example, someone may express their opinion by saying the U.S. invasion of Iraq was a moral outrage. Though this sentence expresses the speaker's attitude, it's still capable of being true or false, so it still counts as a sentence for our purposes. It could be true that the U.S. invasion of Iraq was a moral outrage, or maybe it's not. But in either case, it's capable of being true or false, even if it is someone's opinion. Finally, I want to point out that a sentence can be true or false even though we don't know whether that's true or false. So, take the following sentence. The tallest person on earth has an even number of hairs on their head. So this sentence is either true or false, though we don't know which it is, right? Presumably there is a person who is the tallest person on earth, and presumably that person has to have either an even number of hairs on their head or not. Okay. So similarly, controversial statements for which there is rampant disagreement can still be true or false. Raising the minimum wage would result in lower job growth is an example of such a controversial statement. But though many people believe it to be false, and many others believe it to be true, there is a fact of the matter. It's either true in this situation that raising the minimum wage would result in lower job growth, or it's not. So it is either true or false, even if we don't know what it is. So a sentence can be true or false, even if we don't know it, and a sentence can be true or false, even if it's an opinion. Okay? How do we identify sentences from a logical point of view? How do we identify things that can be true or false? Well, the following is a pretty good test for sentences. So we can ask ourselves, does it make sense to insert "it is true that" or "it is false that" in front of the statement? For sentences, in the logical sense, it does. For other kinds of statements, it does not. So it is true that the tallest person on earth has an even number of hairs on their head. As you can see, we can insert "it is true" before the sentence, and it makes grammatical sense. What about the following? It is true that, can you loan me $20? Well, that doesn't make any grammatical sense at all. I mean, it would make sense to say it is true that you can loan me $20, but that's not what is being said here. We're just taking the question, can you loan me $20, and putting it as true in front of it. And as we can see, that doesn't make grammatical sense. So the sentence, can you loan me $20, must not have been a true logical sentence either. It is true that make your bed is not grammatically correct either. So make your bed is not a sentence from the logical point of view. Okay, let's look at one last class activity here. The last class activity I want us to think about, and so this comes from the third page of your handout, and this will be section B. So let's think about this. A stitch in time saves 9. Can I say, it is true that a stitch in time saves 9? I sure can. So this must be a sentence from the logical point of view. It's something that's capable of being true or false. Can I say, it is true that what is best said and who said it best? No, it seems that I can't. So this seems to not be a sentence according to our test for sentences in a logical sense. And this symbol, just a little cue, is going to turn out later to be our symbol for negation. So that's why I put that in here. So not S. All right, that's it for today. Have a nice evening, and I will get you Unit 3 tomorrow morning.